purpose of this this video, is to create a flowchart that will hopefully make categorizing organic functional groups a little easier, or a process of how you would do it. So first, you ask the question, does the molecule contain both carbon and hydrogen? The answer is yes. It's an organic molecule. The answer is no. It's inorganic. So for example, CO2 is carbon and oxygen. It's got carbon but not hydrogen. Water has hydrogen but not carbon. It's not that these molecules aren't involved in organic reactions or processes, but technically speaking, they are not organic molecules in and of themselves. So once you've categorized something as organic or inorganic, the next question you ask is, does the molecule contain heteroatoms? A heteroatom is anything that's not carbon or hydrogen, but specific examples would be oxygen, nitrogen, sulfur, halides such as chlorine or bromine, etc. The answer is yes. Well, it can be several more things that we'll come back to. But the answer is no. Then you have a hydrocarbon. Simply named because, well, it's got hydrogen and carbon in it. And of that, there are four major categories. There are alkanes, alkenes, alkynes, and aromatics. Those four groups. It's going to be one of those four. Alkanes are all carbon-carbon single bonds. So there's carbon-hydrogen bonds in all of these, but an example would be carbon propane. All carbon-carbon single bonds. There's lots of different alkanes, but the defining characteristic is nothing but single bonds between the carbon atoms. They can be cyclic, like a ring, but again, carbon-carbon single bonds. Alkenes have at least one double bond. Fill in, give each carbon 4 bonds. That would be an example of an alkene. That double bond. 1, 2, 3, 4 bonds in this carbon. 1, 2, 3, 4. 1, 2, 3, 4. That's an alkene. An alkyne, and they have at least one triple bond. Example, is acetylene, but it's got a triple bond in it. 1, 2, 3, 4. 1, 2, 3, 4 bonds to the carbon. It's an alkyne. And then an aromatic has to have this type of structure. Double, single, double, single, double. What's on the left is a shorthand way of writing this molecule. But you got 1, 2, 3, 4, 1, 2, 3, 4 around everything. So an aromatic, you've got to have a ring. You have to have a ring structure, and you have to have alternating carbon-carbon double and carbon-carbon single bonds. Double, single, double, single, double, single. There are other types of aromatic compounds that can be more than one ring, can be rings fused together, but for our class, that's the predominant motif that you see. It's also called a benzene ring. So those are your 4 categories of hydrocarbons. Okay, now back up. Okay, if we go back up the page, sorry about that, to the question, does the molecule contain heteroatoms? So oxygen, nitrogen, sulfur, chlorine, bromine, for example. You're going to create a new page that's going to have its own category.